Welcome into this lecture of day 2 of Motoko Bootcamp. Today we'll talk about characters, text, and iterators. So the first topic on the list is the type char for characters. It's everything from alphabet, letters, digits, and any other character. You can declare that in Motoko using this syntax. Be careful because if you have multiple characters, it's a text and it's not a char. Okay, so for a quick demo, I have an actor that is already set up and I have all the files, fx.json. And we can declare a character, as we've seen before, with the following syntax. So let's see of type char is equal to C. As you can see, I'm using single quotes. If you use double quotes, Motoko will think that it's a text, so we can try. And you will see an error, literal of type text does not have expected types. So you need to use single quotes. A character can be a letter, can be another number, so like this, for example. And it can even be some other character. So we have, let's say, this one. So yeah, you have quite a few characters. When we play with characters, we can import the char module, like this, from the base library, and it contains manipulation and functions that you can use on characters. To find more information on the char module, we can go to internetcomputer.org, and we can go on the right corner, type char, and then the first result will be the char module documentation. So we have the type, definition of what is a char. As we can see, a character is represented as Unicode, which we'll see later. And then we have the functions that we can use with all the function signatures. So for example, we can take a char and convert it to a NAT32. We can take a char and convert it to text. And we have all those functions. So maybe we can try one just to see how we can use those functions. So let's say we want to use isDigit, which will return true if our character is 0 or 9, a digit between 0 and 9. Otherwise, it will return false. So in order to try the module, we can create a test function like this, so public function test, and it will return a boolean, and we just want to try it out. So let's see char.isDigit, and we will code it on C, which is defined here, and is the character C. So it should return false. We can deploy our example. So the canister is called example. And then, so if we call tests, we should get false. And it seems to work. So just a warning on the test function that I'm using here. It's to show some code examples and go through the code with you, but this is not a proper way to do tests in Motoko, and there will be a dedicated lecture on tests. So one thing that can be surprising with the type char is how the type appear in the terminal, and I'm going to show you this through an example. This function is called text to char. It will take a text and return all the characters of this text inside an array. I've done that using array.append, which is not the proper way to do it. You should use a buffer that we will see later because the buffer is more efficient. This will, every time the loop is running, it will create a new array and put the values inside. So this is not efficient in memory and space. This is just for the example. So I've already deployed it. Let's try it out. So text to char. And let's try hello. And as you can see, we don't get the characters as expected, but we get those numbers, NAT32. And so this is related to what we've seen in the documentation, is that characters are implemented as, are represented as Unicode points, and I'll explain that. Before we talk about those Unicode points, we need to talk about ASCII, which is the ancestor to Unicode. ASCII is trying to solve a question, which is how to represent letters inside a computer. And the way to do that is to associate with each letter a number, and then encode this number into binary, and then computer can understand binary. So each letter in ASCII, which stands for American Standard Code for Information Interchange, is going to have a number associated, and then this number is going to be encoded and stored inside the computer. And that's how you can represent letters with a computer. ASCII can represent 128 standard characters, which is enough for the alphabet, the digits, and some characters. Unfortunately, it's not enough to represent all characters that exist. It's not enough to represent emojis, it's not enough to represent characters from other alphabets. That's why we have to come up with another standard which extends ASCII. It's Unicode and it can represent almost anything you can think of. And Unicode is compatible with ASCII. So I am back inside the same actor as before, but I've cleaned up the code so we can start again from a fresh perspective. So we have imported the Char module again, and we are going to print D of type Char, but it will be capital D. And then we will write a function tests, and inside this function, which will return nothing, I want to print something. So I'm going to present a new module, which is the debug module. And this is useful for printing informations. So if you do debug.print, you will be able to print things inside your terminal. And we want to print, basically, we want to convert the Char to a NAT32, which will be the Unicode representation. So this will be a NAT32, but this command can only take text as input. So we need to convert that to text. And there is a special one, which is debug.show, that will convert anything you have inside the parentheses into a text that can be printed by debug.print. So let's deploy our actor. And if we call the function tests, we have nothing that is printed because actually debug.print, the output of this command is shown inside the replica terminal. So we can go here and we can see that we have 68, which corresponds to the value in the table. So everything seems to work. One thing to note is that if you're using debug.print, you can only do this if you are using a local replica, because on the internet computer mainnet, you don't have access to this tab. Actually, this tab doesn't really exist anywhere. So there are other ways to print information. For example, you can use logs, but you cannot really depend on this debug.print. The next type is the type text. A text is a sequence of characters. It can be a word, like hello, can be a sequence of digits, or it can even be the combination of the two with the concatenation operator. We can define a text with the following syntax. Let t of type text is equal to hello. One thing that we can do with text is get the size of the text. So let's say s of type nat will be t.size. And the size corresponds to the number of characters. So in that case, that would be 5. One other thing that we can do is concatenate two texts. So let's say we have another one, which is world. We can do something like this, and the concatenation operator is this one. Once again, if we go on the internetcomputer.org website and we go on the text documentation, we can see that we have everything for the text module, which indicates, for example, that we can access the size, we can concatenate text, and of course we have the list of functions here. One thing that you will note on this page is that you have something called pattern, so it's a type, which is defined as follows. A pattern is either a character, a text, or a predicate. So a character will be a character, can be like C, B, A. A text will be a word or anything that we've seen before. And a predicate is going to match a character with a Boolean. So for example, a predicate could be, is my character a digit? So if it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then it will be matched to true, and the predicate will be validated. This is really useful if you want to do manipulation on text. You have to understand what is a pattern. And then you can use patterns to, for example, return true if a text contains a match for the pattern. So let's try it out. One important thing to note regarding pattern is that by default, this type doesn't exist in Motoko. So if you write something like this, which is a valid pattern, you will get an error unbound type pattern. So to import the type, we need to import the module because this is inside the text module that pattern is defined. And once we do that, we can import the type as follows. So type pattern is text dot pattern, and the error has disappeared. So that's our pattern. Now we want to try a function. So let's say we want to try a text which is like, let's say Motoko, and then we want to check if C is contained inside this text. So to get this information, we can do text dot contains, and it will take a text and a pattern. So the text we want to test is Motoko. Sorry, we can use the variable, the text, and then the pattern is P. And so this will be returned by the function. So if we deploy this function, we should get no. So we can try it out. Once again, it's the same canister that I've been using for the whole video. And now we can call tests, and it returns false. And maybe if we have something else, like bootcamp, we should get true this time. So we need to deploy again. And we got true. So this was one type of pattern, but we also have other types. So for example, we could have a pattern like this. So P2 of type pattern, and it will be this time a text, and then the value of the text inside of it. So auto up, and we should try it out with text2. So let's maybe, yeah, like this. So I think we should get false because there is not this text inside. And then if we modify with the Motoko, yeah, like this, we should get true. And that's it, we get true. And the last type was the predicates. This one is a bit more involved, but we can try it out. So it's a predicate. And basically we need to input a function that will take a char and will return a bool. And for example, that could be something like, let's say char.isDigit. So for that, we need to import the char module. And so maybe we can change that to this. So it will basically, if we do text.contains with the pattern number 3, this will test if there is any character inside the text that is a digit. So we have this, which should work. So if we try with text2, we should get true. And with text1, we should get false. So true, and now we can redeploy again. And then we can call this function, and we got false. So that's perfect. Two other functions that can be really useful in the text module are encode UTF-8 and decode UTF-8. So UTF-8 is a common standard that is used to encode text across the web. And we can convert text to blob and get text from blob. So we can try it out. Just need to import the text module again. And we will create a public function that take a text and return a blob. So we're just gonna copy the function. Text.toBlob. one thing that is not explained in the Motoko Bootcamp documentation so far is that we don't really need this return every time. You can put it, but you can also just have your expression and the latest expression that is evaluated. So in this case, this one, because there is only this, but this is the latest expression that will be automatically returned by the function. So let's try out our function text2blob. We can do something like this. We can call hello. And as you can see, we have the answer, which is a blob. It's the candid syntax. But maybe you want more information because we don't really see any information on the blob itself. We just see that it is encoded, but we don't see how it is encoded. So if you want more information, you can do this and add a flag, which is called output, and it will change the type of the output. And we can use row. And so with row, you will see the hexadecimal. Of course, we also have the public function, also have the function blob to text. But in this case, we need to be careful because the text that will be written is optional. This is to prevent, this is to take care of the case where the blob that we give is not a valid UTF-8. So I guess if we try to deploy that, this will be a bit annoying to test because of the candid syntax, but we can do hello. I think we can do this blob hello. And then if we, let's try it out. Okay, so blob to text. And it should return hello. Yes, optional hello. The last type for today is the type Iter, so iterator. I remember that when I started Motoko, it was a new concept for me and it was a bit confusing. So I think a good analogy is in Super Mario, you have those blocks that you can jump on and you get coins, coins, coins until the block is empty and you get nothing. And the iterator is pretty much the same. You can consume it, you can call it, but then at some point the iterator will be empty and it will return a null value, and that's how you know the iterator is consumed. The easiest way to understand what is an iterator is to use one. And we can do that by importing the Iter module from the base library. So it's the same syntax as usual. And then we can create our first iterator with this syntax. So I equal iter.range. So we will go from 0 to 10. So this iterator is going to call all the numbers from 0 to 10, and then it's going to return null, and that will be the end of the iterator. Actually, iterators are very often used with loops. So we can do something like this. I will first create a function test. And then for, let's say, number in E, we can do something. So we can do debug.print, debug show, oops, and then number. So this will actually call all the values inside the iterator, and we will see that. So we just need to deploy. Okay, so our canister has been deployed, and I can call the test function. And I should be able to see, yes, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this seems to work as we want. So I've decided to talk about iterators today with character and text because those concepts are related. So if we have a text, if we have like a text like this, again, Motoko, then we can do something. So we can actually iterate over all the characters in the text. So just need to do that. And then we can do for, let's say, letter in t.char, cars. So this is like going to create an iterator based on the characters. And then again, we can do debug.print the letter. just need to make sure that, oh, it's a car, so we need this debug show again. And we have imported debug. And again, if we try to deploy, and then try to call the test function, we can see all the characters. So Motoko. So once again, new type, new module, and new documentation. And the module always starts with the definition of the type. So this is the formal definition of what is an iterator. It can seem a bit complicated because it requires two concepts that we haven't seen so far, which is the generic types and the optional types. It will be explained in more details, but just for today, a generic type can be any type, can represent anything. So it could be a nat, instead of t, it could be a nat, it could be a char, a text. And the optional type represents the type or the value null. So the value null is used to represent the absence of value. And in this case, it represents the end of the iterator. If the function next that we can call on the iterator returns null, it means that the iterator is consumed and the iteration is finished. Another time when iterators are useful in Motoko is with arrays. So let's say we have an array. This time will be an array of text. And let's say we have languages, so like Rust, Motoko, TypeScript, Python, and so on. We can actually use, again, a for loop, so public function test, turn async. So for language in array.vaults. So this is, again, the same kind of structure as with when we did the text.cars. Again, this is an iterator here that we are creating, and we are instantly using it in the for loop. And we can show that. So let's try that. And this is working as expected. With the iter module, we can also create iterators from our data structures. So like if we have the array, we can do iter.fromArray. And then, so like let e is equal to iter from array, and then it's like this. And then the array that we want. And with that iterator, we can actually use it to get the size of the array. So iter.size is going to take an iterator, and it's going to disregard whatever is inside the iterator, but it's going to count how much elements. So it's going to basically return the size like this. So this is a pretty complicated way to get the size, but it does work. So and then can deploy. And we should get 6, and that's it.